Hi, I thought that I'd do this video rather than just giving you a mark scheme and telling you to mark it yourself. I've found a website that does work solutions, and I can talk you through them. And if you've got any questions after this, then you can ask. So, let's get started. First question, factorizing this quadratic. They do it a slightly different way, but you should get the same answer. 7x plus 2 or 3x minus 2 in either order. They start off the same way, which is getting the minus 84 and the minus 8 and figuring out the 6 and the 14. And we do something slightly different with them. They partition them into two separate numbers. We put them into two separate brackets and divide, but we all end up with the same answer. Solve. For each bracket to 0 and solve, you get minus 2/7 and 2/3. That's straightforward enough. You would get error carried forward marks if you had factorized the first one wrong. Completing the square. So halve this number to get x plus 6 all squared. Now if you imagine expanding that, you get x squared plus 12x plus 36, which we don't want. So you take away the 36. You've still got that plus 49 on the end. They combine to make 13. And so we've completed the square. And the least value is 13. It's whatever this number is on the outside, including sign. And the value of x is minus 6, because minus 6 makes this bracket 0. And that's how you end up with the 13. Anything other than minus 6 put in there, and this bracket will have some result. You'll square it, and it'll add something to that 13. Differentiating. So they've shown a bunch of workings here. All you really need is the final answer. Everything highlighted in green, as a rule of thumb, is what's required to get the marks. You're going to multiply by your power and subtract 1 off your power. So 9 times 4 makes 36. Take 1 off your power, you get 3. 4 times 2 makes 8. Take 1 off your power, you get power 1, which we generally don't write. Number terms disappear, 3 marks. This one is straightforward enough. Just don't make the mistake of taking 1 off minus 8 to get minus 7. If you take 1 off, you get minus 9. And there's one with fractions here. So stick it in the calculator. If you're at all unsure, there's absolutely no reason to make a mistake just because you try to subtract using fractions in your head and you make it wrong. So a proof question. So proof question, it's always best to start with whatever's on the left, end up with what's on the right. It is not an equation that needs to be solved. It says proof. It's got the 3 lines, which is for an identity. You don't need to figure out what x is. That's not what you're trying to do. So because it's a fractions question, you want to get a common denominator. Just make sure that whatever you times the bottom by, you also have to times the top by. Also remember, if you've got more than one term at the top of a fraction, that you've got to times each term by it. And as far as what common denominator, well, it's pretty easy. If you glance over the right, you're going to be making that into a 70. So times in this one by 35, this one by 14, and this one by 10. Another thing to make sure you are careful about is this minus and this minus combine to make a plus 84. You should always just work it all the way through and double check you get what's ended up on the right, because if you work it through and you don't just say that you do, because people will notice. They're looking at these workings, because it's proof, because they give you the answer. Your workings is what's important. That's what you're getting the marks for. So differentiation by first principles. Again, it's done slightly differently here than I've done in class, but it's got all the same key principles. So we do it all in one step. What they do is they'll get that top line, they'll subtract the y, whereas we had this take away the y anyway, changing y, over changing x, changing x is always delta y. So they divide through at that point to cancel it out. We write it out as full steps, but you get to the same points. And then remembering to put your limit as delta y tends to 0. you got dy by dx. It's going to equal 2x plus 3. This is just something you would just have to learn, and it does come up in A-level maths, so it is something you've still got to learn, unfortunately. Right, so quality of written communication sort of question. Cylindrical package made with a radius of 4 centimeters and height of 18. We've got the net is drawn on a thin rectangular card. We've got 3 pieces used to make the package. Circular ends fit exactly. And calculate the area of the thin rectangular piece of card so that we don't waste anything. So the length of the card is 34. The reason you get that is because it's 18 plus, well, if the radius is 4, the diameter is 8, so it's 8 and 8, so that makes 34. The width of your card, so it's going to be the same as the circumference of the circle, because they said there's none wasted and it makes a cylinder. So circumference of the circle is either 2 times pi times r or pi times diameter, which is 8 pi. And then we've got the area of the card, length times width, so 34 times 8. And then we've got, that's the entire area of the card. But the area of the 2 circles, we've got the curve, well, it says curved surface area, but that's it's flat here. It's just this 18 by 8 pi. And so that's 144 pi, so that we can work out the wasted card. Don't round until the last moment, because that's how you're going to get an accurate answer, but they are still tolerant. They would accept anything in the range of 300 to 302. And because it's a quality of written communication question, just some basic things, just a little indication of what you're working out, units, workings, and just being crystal clear with everything just makes it easier for them to give you those marks, because the level of maths in you is not that hard, but there's lots of marks available. Just don't throw any of those marks away. So it's these questions which you're not meant to use a calculator to do. You can just type this into your calculator, press equals. It will tell you exactly this. Write it off to the side, and you'll know exactly what you're meant to end up with. So that's your way of checking, but you still got to work through it properly. So you're always going to times by the conjugate. What's the conjugate? It's the same as the bottom, but with a minus instead of a plus. The reason we're allowed to times by that is because this fraction is 1, so we're not affecting its value. And the reason we want to is because of this plus and this minus, all the square roots are going to cancel out. The whole point is simplifying it means that there's no more square roots on the bottom. Even if this looks more complicated because the numbers are bigger, there's no more square roots on the bottom. So you work at the top as normal, there will be square roots left there. You work at the bottom and they cancel in the middle, and these just combine to make 23. Remember that it's not just 5 times 5 and root 2 times root 2. You've got those middle terms that are meant to be written down there, and they cancel out. And simplifying these. So what we are going to be doing is working at the top line first. So multiplying things in index form, add to the powers, use a calculator, do minus 2/5, add 17/5. If you use a calculator, you're going to get the right answer. You try doing it in your head. There's no sort of benefit to that, and it's not, even though the question says don't use your calculator, they're not checking that part of your maths. So you can just see here that just add them together, you write down the answer, it's 3. Then fraction means divide, so you're going to subtract a half. Your calculator tells you that's 5/2, so you write that down, you got the answer. They're doing slightly differently, but we factorize out, and what we factorize out is whatever's on the bottom line. So if you factorize out x to the 2/9, you're going to get x to the power of minus 1/9 on the inside. You factorize everything out in the second term, so it's just going to be plus 1. What's outside the brackets and at the bottom is going to cancel out, and you're going to be left with the correct answer. Coordinate geometry. So calculate the distance, so the length of the line, so it's Pythagoras. You could draw a little diagram with some rough positions of coordinates and realize how long the triangle is and how tall the triangle is, and do Pythagoras the long way. But the distance between 2 points formula is this one up here, and it is useful if you can remember it because it saves you a lot of time and effort drawing out those little diagrams. As far as which way round you subtract things, because they've done the 4 take away -2, if you did -2 take away 4, it will get you the same answer, because 6 squared is the same as -6 squared. That's the whole point. And then you do the same with the second coordinate, square root, and you're going to get that it's 10. Gradient, so it's changing y over changing x. So changing y, 6 take away 14, over changing x, 4 take away -2. Again, if you did it the other way around, if you did 14 take away 6, that's not a problem as long as you're going to do it the same way round on the bottom. This 4 and this 6 are from the same coordinate. This 14 and this -2 are from the same coordinate. You have to keep them that way round. But whichever way you do it, you stick this in your calculator, press equals, it tells you -4/3. Right, so find the equation of the straight line that passes through the midpoint of the line FG and is perpendicular to the line of FG, and express your answer in this form. Okay, so there's a lot to work out here. So what we need to do for these questions is just write out little things, just work them out piece by piece and put them all together. So it's talking about the midpoint of FG. So we work out the midpoint. Midpoint is you add up your x coordinates, add up your y coordinates, and halve them. You add up your x coordinates, 2, -2 and 4, halve it, you get 1. Add 14 and 6, halve it, you get 10. So you got your midpoint. It's perpendicular to FG. So what does that mean? That means that it's got the negative reciprocal gradient. We already worked out the gradient for this was -4/3. So negative makes it positive in this case because it's already negative, and then reciprocal turns the fraction upside down. So we've got a gradient of 3/4 and a point of 1. And if you use y equals mx plus c, or y minus y1 equals m brackets x minus x1, you're going to work out that c is this. You're going to get an equation which looks a bit like this, but because it wants it in the form a, b, and c, where a, b, and c are integers, whole numbers, you've got to multiply throughout by 4. You've got to move everything to the same side, and that way you are going to get the answer in the form that they want. You'd lose your final mark otherwise. Whatever's on the bottom, you always multiply through by that, and that's what gets rid of the fractions. Right, coordinates and nature of stationary points. So stationary points means where the gradient is 0. So if we differentiate, you get 3x squared minus 6x. Equate it to 0, solve, you get your x coordinates. Put those x coordinates back in your original, and you're going to get your coordinates, your stationary point, 0 and 11, 2 and 7. The nature means are they maximums or minimums? So what you do then is you differentiate again. So we take this 3x squared minus 6x, differentiate again, you're going to get 6x minus 6, and then put in our x coordinates. You put in 0, it's less than 0, which means that it's maximum. If you put in 2, you're going to get something that's bigger than 0, which means it's a minimum. It's counterintuitive, but less than 0 maximum, greater than 0 minimum. Got all those steps in your exercise book. Just follow those steps, and these questions are pretty straightforward because they're always the same. Okay, trigonometry without a calculator. So again, you can use a calculator. You've just got to break the question down into real tiny parts. You type into your calculator cos 45, you get 1 over root 2. You type into your calculator sine of 45, you get 1 over root 2. Write those down individually. Then fraction means divide, so you can write them as divide or as a fraction. Again, you can type this into your calculator, press divide, press equals, it'll tell you 1. You can get this mark by putting it all in your calculator, just little by little by little, showing all the workings. Same thing for this one. Type into your calculator sine 30, you get a half. Type into your calculator sine 60, it tells you root 3. If you put in 1 divided by the other, so you write it out, then you should be rationalizing the denominator by multiplying top and bottom by root 3. But again, if you just press equals, it will simplify this for you. And as long as you show this intermediate working, you can just write down that answer as well. The reasons why all this works, either think back to the graph or think back to those triangles that we did, which explain why this is true. Sine 60 bracket squared is written as sine squared 60. Simplify sine squared 60 and tan squared 45. So type into your calculator sine 60, you get root 3 over 2. Type into calculator tan 45, you get 1. Square them individually, add them up, and you get your answer. You can use a calculator, you've just got to show all your intermediate workings and break it into little steps. Okay, so find the remainder when it's divided by x minus 4. So you could do your algebraic long division, and whatever the remainder is at the bottom, that's your answer. But if you just put in 4 into this, whatever the answer is your remainder. And that's by far the easiest way. Okay, whatever would make this x minus 4 0, which is 4, that's what you put in. Show that x minus 2 is a factor. Well, again, the easiest way of showing that it's a factor would be to put in 2, show that the result is 0, remember to have a conclusion. But the other way of doing it would be algebraic long division. Okay, now they do comparing coefficients, which I may remember if I showed you this in class. I think I did, but by far the better way of doing this would be algebraic long division. So you'd be doing x minus 2 divided by this divided by x minus 2. You would end up with, once you've done that properly, a remainder of 0 and a quotient of x squared plus 8x plus 15. And then you factorize that as normal, and then don't forget to write down all 3 of your factors, one after another after another. Number 11, so sketch some graphs. So it's a pretty tricky one. It's having 3 different things happen to it: the minus, the 3, and the 5. And you've got to remember what order they happen in. So start off with your base graph, which is your cos graph. Then the minus, that reflects it, turns it upside down. Okay. And then the minus 3, because we're going in bid mass order, you're going to do that 3 before that 5. That stretches it in the y direction. So the 1 and minus 1 become 3 and minus 3. And then the plus 5 moves it up 5. So up 5, that becomes 8, and that becomes 2. So the whole thing is above the axis between 8 and 2 and upside down. And then it says state the maximum and minimum value. So maximum, that's the highest it goes to, is 8. Minimum, that's the lowest it goes to, is 2. So it's easy enough. Once you've done the graph right, you would get error carried forward there. Find d2y by dx squared. Differentiate twice. Differentiate once, you're going to get 21x to the 6 plus 4. Differentiate again, you're going to get 126x to the 5. Integrating. So add 1 to your power, divide by your new power. Remember the plus c at the end. So add 1 to your power, divide by your new power. Add 1 to your power, divide by your new power. Add 1 to your power, so minus 2 plus 1 is minus 1, divide by your new power. Remember the plus c. The examiner will accept that, but it is always best to simplify things. So the 4's cancel, the 2's cancel. This minus makes the sign a minus, and x to the minus 1 can also be written as 4 over x, and you've got that plus c at the end. And showing all your working. It says showing all your working because there are some calculators you're allowed in the exam which can do this for you. And it's not really a help because they will always put showing all this working. So it could be used as a check, but it's certainly not worth buying a new calculator for. So you integrate as normal, add 1 to your power, divide by your new power. Add 1 to your power, divide by your new power. Remember that number terms become x terms, but now we put it in square brackets with limits. We simplify the terms, so you got 4x squared plus 2x. You put in the top number, you put in the bottom number, you subtract them. Show you're working, because it says show you're working. And that's fairly straightforward, 5 marks there. Find the equation of the tangent. So equation of tangents, that's another thing which you should be thinking about differentiation. So you differentiate to get 6x. You put in x is 3, and that tells you the gradient of the tangent. If you think about the shape of the graph and you're looking at the gradient of that point, think about back to GCSE when we drew tangents on graphs and measured the gradients. Now we're going to differentiate to find the tangent gradient. You put in the 3, you get the gradient of 18. So we've got the gradient, and now we want a point on it. So we've got the x point is 3. If you put 3 in here, you're going to get the y coordinate is 33. So now that you've got the gradient and you've got the coordinate, you can either use y equals mx plus c or y minus y1 equals m brackets x minus x1, and you're going to get your answer. Does it say what form to put it in? It doesn't. So if you left it with fractions and all on one side or whatever other form, that's fine, but you should be getting this. This is a straightforward way of doing it. So, algebraic method, the coordinates are points of intersection of the curve. So it says algebraic method because it doesn't want you guessing. It doesn't want you thinking, oh, it could be 4 and 6 and 5 and 5 or other things. It wants you using the proper algebraic method. And the way to do that is you take the simpler equation and you make y the subject, which we've done here, and then you substitute it into the more complicated equation. That gives you a quadratic. You solve the quadratic. And once you've got those x values, you put them back into the simpler equation to get the y coordinates. Okay. And because they're whole numbers, they are guessable, which is why you've got to show your workings and show an algebraic method, because they would not accept guessing. Okay, we've merely sketched the curve. She states that the points lie on the curve. Is she correct? Or show that she's correct? Well, you just got to substitute the numbers in. You've got to show when x is 2 that y turns out to be 0. When x is 4, y turns out to be 0. So if you ended here, you wouldn't get the marks. You've got to have some little conclusion. It's only a couple of words, but a little conclusion is needed. Area under the curve. Okay, that is by integration. So integrating between 4 and 2. So you're integrating between those x values, the 4 and the 2, and that'll give you the area under the curve. You've got the equation of the curve. Add 1 to your power, divide by a new power. Add 1 to your power, divide by a new power. Number terms become x terms. We also don't need to worry about plus c because they would just cancel out. Square brackets with the limits. You put in your higher number, you put in your lower number, you subtract them, you get your answer. That's the end of the paper, right? So I went through it a bit quick. Perhaps you'd have to pause it, look at certain things. But if there's something you think I didn't explain or you didn't understand or you're still not sure about, then just email me or message me on Microsoft Teams and I'll get back to you.